Hello, my name is Rudy Hill, and I've been working as an FPGA engineer for the last 5 years. And we're continuing to talk about digital design and jumping right in from the last video. I just kind of had the notes pulled up, but basically, we talked about truth tables. Great, you know about truth tables, go wild with it, learn new stuff, learn new properties. We're going to, anyways, but we're going to shift a little bit. We kind of went from more intuitive understandings of statements and true and falses. But we're going to have a more formalized math, and we'll call it Boolean logic. And let's just start. Here's the big idea. Um, we're trying to turn this more mathematical, more theoretical idea of true and false, and we're going to convert that in eventually into voltages. And I kind of showed you a little bit if you didn't watch my videos. But here's the long story short. I'll just jump straight to the chase. Um, True T is 1. I don't usually put tails and stuff, but just to be clear, that's a 1. False is a 0. So, of course, eventually, this is going to be some sort of VDD. We'll just say, yeah, fine, VDD. And this is going to be 0 volts or ground. So I'm just kind of giving you a preview. We don't have to be totally theoretical, like, act like we're dumb. We don't know what bits are. We don't know what voltages are. So that's kind of what we're doing. So we can just have um, some basic description and say that, okay, so the same thing where instead of P and Q, we're just gonna kind of just terminology. We're gonna have A, B, and C, and we're not gonna call these just operations anymore. We're actually going to use these as operators. So I'll just kind of explain it instead of yapping about it. So it's kind of like this. We'll say that this is A, B, and C, and this is an AND gate. And so the truth table, kind of exactly what we are doing before, is the same thing before, where there's A, B, and C, except here's what we do. We do the falses, trues, whatever, and then since this and, just kind of go down the line. We know how this works now. Actually, I'm going to move this over because I'm showing you the actual circuit diagram. Because so I'm kind of mixing a couple of things. This circuit diagram corresponds to this. And actually, I'm going to get into what we're actually going to properly call Boolean algebra. I'll kind of move this here actually, because we'll say that the more mathematical way to put it, the more formal way to write this is actually, I'll be careful with writing that. You'll see why. But this is like kind of A multiplies B. So that's kind of how it looks like. So we could also say AB. And you'll see kind of why this makes sense. Maybe you'll get an intuition later on, like why this kind of makes sense. It's like multiplying because it kind of obeys some of the same properties of distribution. And yeah, we will kind of see that. But I'm just kind of introducing to you the concept. Um, and so we'll do the same thing here. We'll say that the ORs, A or B, we'll say this in this case C is A or B. So this plus sign, it's like a plus, but it's OR. And we kind of draw this. Um, Let me check my notes. Yes, that's okay. That's right. It is angled. So it's angled like this. You have A, you have B, out comes C. So yeah, I'll kind of just point it out again. I don't know if this is um, the best way to highlight. Make that a little bit bigger. we'll do a bit bigger still. There's that. So that's the Boolean operator for it. And I'm showing the circuit because we're smart here. We're smart here. We can kind of catch on quickly. But yeah, I'll just write it. And there's a very particular way I'm writing this, but it doesn't really matter. It's the permutations basically. So 0, 1, 1, 1. So it's or. So it's one or the other or both. Both is fine. Um, and I actually realized I neglected to kind of talk about some other operator before. And I've kind of talked about it with a sense amplifier actually briefly. But we have a inverter. So this is like a not. So not logically, this is pretty easy. Let me move this down because knots. There's a couple ways to write it. So if we have say A and this is C, we're just saying C is the output. Just kind of keep all these consistent. But there's a couple different ways to write it. A bar, like this bar over, and we'll say that that is C. Another way to write it is not this kind of. I didn't really do it right. Let's just kind of go back. So straight angle, C. Here, actually, I don't like the way I'm drawing this because we're gonna do A, kind of this symbol, and actually this kind of way to do it on the computer with like a tilde. So it's gonna be very simple. All right, you guys ready? An inverter. What do you think an inverter is? What do you think a not is? Um, so we have 0. What do you think is gonna be for C? You guessed 1. You're right. If it's 1, big bucks on the line. What is this? That's right. It's 0. Yeah, so pretty straightforward. I'm kind of interchanging some of these terms. Logically, this is a not. Circuit wise, that's an inverter. Kind of like this is an AND gate, that's a circuit, and the Boolean operator is an AND. So this is kind of how we're thinking about this. And there's a couple different examples of how to use it. It's the same thing. Using ands and ors, kind of what I used before. And actually, I realized something. This is kind of fixing this. I was like, oh, I don't know what this truth table is. There's actually ways to simplify, and there's a reason why this is just Q, right? So that's an example. So really, from the example, this is just Z is Q. So that's just how you can simplify. I just kind of made something up, but it wasn't great. But the more variables you use, the better it will be. But bottom line is, you could kind of have fun. I'm being cheeky, but I'll do something even better. We'll say A and B. That's how we say it. Or C will be fancy. We'll say or not C is equal to Z. And actually, we're going to need a lot of space. This is why I didn't want to do it 3 variables, because it's 2 to the 3 different permutations. I'll write that. Permutations. Let's get in there and write it right. Permutations. And you'll see, like there's reasons why, and I haven't really talked about bits and that sort of thing, but maybe that's another video. I keep saying that, but I'm actually happy. This kind of keeps me busy. Yeah, we'll have see. This is the truth table. All right, so let's just start 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. So let's just see. Let's verify. It's 1, 2, 3, 4, 5, 6, 7, 8. I'm running out of space, but it's gonna be okay. Yeah, so we could just kind of go through. I'm kind of just doing this in my head. I could write it out, but you guys are smart. So yeah, so like let's just go through. So this is just an example problem. I'm just jumping right into it. Saying here's what I thought uh with 0 and 0 or 1. We're saying because that's an or. Oh, sorry, or not 1. What is that, right? 0. So it's basic. So we're just reducing. So I'm just kind of just doing this for example, but basically this it's like a times. Basically 0 times whatever is always 0, right? So this is why I'm saying like some of this multiplication stuff and addition stuff, it's great. What's 1 plus anything? In Boolean math, 1 plus anything is 1, right? In this case, 0 times 0 is 0. 0 times 1 is 0. 1 plus 0 is 1. 1 plus 1 is 1. So that's kind of I'll write it down actually. We'll kind of let's talk about this a little bit actually. But before we move on with our example problem. This is all or, right? This is a 1 or 1. Right? What is 1 or 1? 1 or 1 is 1. Right? True or true is true. Um, kind of what we had shown before. What's this? And this is we can I forgot what the property is, but basically you could change the order. This is actually the same. 1, 1, 0 or 0. So this is just ors. I mean, this is just ors. I'm just kind of showing you that if you want to think about addition, that's how you can think about it. What's 1 plus 1? 1. What's 1 plus 0? Um, but it's Boolean because we're kind of capped out at 1 or 0. So there's not more digits. That's the way to think about it. What's 1 plus 1? 2. Well, we don't have 2, logically speaking. So it's just 1. So and another way to think about it, I'm just kind of writing or all of these ideas are the same. So this shouldn't be anything new. If I were to write it differently the other way around, it would have been um, actually maybe I'll do that. This video is gonna be kind of long, but maybe it's important that I explain it now before I move on. And if there's any confusion, maybe I'll make another video. But hopefully this will be one and done. But like um, we said, let's kind of do it before. I'm just redoing the or truth table, but in a way where you can kind of get a grasp for this Boolean math. Maybe I could have done it before, but oh well. We're doing it now. We're doing it now. Um, whoops, and that's not the right sign. Or, and yeah, so 0 times 0. So this is what kind of my intuition for this. 0 times anything is always 0. Um, yeah. I think this makes it a lot easier to write actually and kind of think about. And we can kind of think about distributions and we'll kind of talk about that with De Morgan's theorem, but let's just say we had a b or c in parentheses, it's actually logically equivalent to ab or ac. Yeah, we won't talk about that. You could kind of do that on your own time, but you can kind of see that's the same. In fact, we're going to kind of talk about this here. So yeah, we're just kind of going through this. Let's go back to this truth table. And now that I kind of showed you that, it's okay. Maybe we can have some intuition for this. So 0 times 0 plus not 1. What is that? So we're doing this times 0 plus, I say plus, but again, this is kind of it's notation, right? But 1 or, technically it's or, 0 or 0. So the 1 or 0 plus 0, again, it's just going to be 0. Okay, great, great. Um, we're just kind of filling in. Oops, actually, I messed up. I messed up. Why don't you guys correct me? This is 0, right? I filled in C as 1. So this is actually 0 because 0, this is 0 or not 0, 1. So this is 1. Okay. Okay. So yeah, I'm just doing this third line here. So we reduce that at 0 or not 0, so 1. So 0 plus 1, 1. Okay. I'm just showing you how you would fill out a truth table. So let's do it again. 0 times 1 plus not 1. So 0 plus not 1, so 0. So this is 0. So I'm just kind of changing the terminology just so you can get pretty fluid with it to know, to understand kind of what I'm getting at with all this. So it's like 1 and 0 or not 0. Um, this is going to be 0 or not 0, so 1, 1. Just like something very interesting about this that I'm noticing already. Great. What's our next one? 1 and 0 or not 1. 0 or not 1, 0. Very exciting stuff here. So, yeah, I'll just kind of do it straightforward, but there's kind of shortcuts you can kind of see. Kind of what I already know what the result is going to be, but this is your first time. Hey, this is not my first time, but this might be yours. So probably yours. So 1 or not 0, so 1. So we know this is 1, and we'll kind of keep those ones there. It's not what I wanted. Okay, not 1, so 0. But it doesn't matter because it's an or, so it's still 1. So yeah, that is the truth table. So I'm just kind of showing you how you kind of use these operators. Again, if you actually had inputs, and I alluded to it before, and we'll talk about it more later. Um, but I was just showing you the Boolean algebra here, but also telling you now, if you're an electrical engineer, you're a circuit designer, that yeah, actually we can implement this in a circuit, and that is related to when I was talking about CMOS and NMOS, and we are going to come back to that, where you can not just implement it, we can implement it with those with MOSFETs. And so we have the math, we can implement it with transistors and represent it like this, um, with ors and nots, and there's more circuits. There's more logic, and we'll kind of talk more about that little by little. But yeah, once you can kind of stack logic, you can stack calculations, you can stack math. We'll get there. We'll get there. Um, so, anyways, that's just it for today. So, yeah, thank you for watching. If you had any questions, please feel free to comment your question. And if this video was helpful and you liked it, drop a like. All right, that's it. See